Good morning. We were discussing about the manufacturing process of various insulator technologies and also the handling of these insulators used for transmission. The manufacturing plays a vital role for all the insulator technologies, porcelain, ceramic or glass or composite polymer type of insulators. So, equally importance has to be given for the handling, material storing and the dispatch processes. So, now we will discuss about the importance or a brief introduction to the design criteria for these various insulator technologies and the importance of the insulation coordination. So, why insulation coordination is an important criteria for the selection of any of these insulators for the transmission or the distribution or for the traction purposes. So, we know that in the power system the equipments are likely to face over voltages. These over voltages in the power system are of normal power frequency over voltages. This could happen because of the disturbance in the system, sudden throwing of loads or due to the internal disturbances. These power frequency over voltages could span over few cycles and where the insulation integrity is to be maintained for the smooth performance. Second important is the lightning over voltages which the equipments face in the field. The lightning over voltages are of typically 1.2 by 50 microseconds, where 1.2 being the front time of the waveform, it is a double exponential waveform. So, 1.2 is the front time and tail time is 50 microseconds. So, this lightning over voltages when impinge on the system could deteriorate the performance. So, the equipments have to be protected for lightning over voltages. Further to this, at a very higher voltages about 220 kilovolts, switching over voltages, this switching over voltages could develop because of the closing and opening of the circuit breakers, where the surges typically of 250 by 2500 microseconds. So, 250 is the front time of the surge, the 2500 is the tail time of the surge. So, these waveforms which could cause damage to the insulations have to be taken care. So, lightning surges, switching surges, normal power frequency operating surges could cause the insulation deterioration which of any equipment of the high voltage in the high voltage substation or in the transmission or a distribution have to be taken care. So, for this a proper design criteria has to be evolved and proper insulation coordination has to be done. So, this will help in the better management of all the equipments which are in the field. So, the insulation coordination to be done for any equipment and to see that the maximum over voltage stress, this maximum over voltages as mentioned earlier could be because of the power frequency over voltages, lightning over voltages or the switching over voltages. This stress which is developed because of this could happen rarely, it is not an event continuously which happens, and likewise the insulation strength also rarely decreases to the lowest value. So, this point has to be considered first. It is not that continuously the over voltages are seen by the equipment in the power system network. So, the likelihood of both these events, that is occurring simultaneously, is very limited in number. Hence, a considerable economy may be achieved by recognizing the probabilistic nature of both these stresses and the insulation strength by accepting some risk in the design of this equipment, so that substantial economy can be saved. So, this could lead to a decrease in line insulation spark distances, so tower dimensions, weight, right of way, and this results in a decreased cost of line. So, several of these factors have to be considered while designing the line insulation and proper protection. So, the decrease in line cost must be weighed against the increase in the risk of failure and also the cost of such failures. So, insulation coordination basically or primarily aims at selecting proper insulation level for various voltage stresses which are developed in a rational and a balanced manner. So, the main objective as mentioned is to assure that the insulation has enough strength to meet the stresses which it faces in the field. It is lightning because of switching or because of the power frequency stresses which are developed at an instant, and whether the insulation will be able to withstand this. So, the main aim of the insulation coordination is to protect all the equipments, components and the devices, and necessary insulation coordination is to be properly done. So, this is the philosophy of insulation coordination. By seeing these two figures, we can know the importance of insulation coordination. The first curve gives the kilovolts peak to flashover voltages on the y axis, and x axis is the time of time. So, this gives a volt time curves. Here you can see the typically curves, VT curves or volt time curves are plotted for various equipment like LA. The curve A represents the curve for the lightning arrest, the kV peak to flashover voltage to the time. Similarly, for the line insulation for a transformer, the curve B is shown here, and for the bus bar typically it is D. So, in this is how the kV peak to flashover voltages versus time for various equipments which are operating are shown. When you closely monitor here, to protect the transformer, we use a lightning arrestor, where the lightning arrestor in case of over voltages could be of lightning or switching over voltages, this lightning arrestor should act and see the protection is made for the transformer. So, this is the important information. And in the field, as I mentioned, temporary over voltages, these over voltages are lightly damped oscillations at supply frequency. So, it could last for few cycles at 50 hertz or 60 hertz operating frequency. The second which because of the opening and closing of the circuit breakers, which we termed as the switching over voltages, where the wave could be of 250 by 2500 microseconds. This is like a damped oscillations at frequencies which could be lesser than 10 kilohertz. So, the lightning over voltages which occur due to the natural lightning, these are basically the damped oscillations at the frequency range below some 100 kilohertz. So, this is some information of how the equipment is to be designed for various over voltages. The second curve here you see the voltage versus the time again. This is the volt time curve which could be constructed. You can see for any equipment there is a rated withstand level for the equipment. You have a critical withstand and a critical flashover. So, critical withstand, critical flashover and rated withstand, these are the important values of any equipment has to be able to withstand in the field conditions. So, the designer of the equipment will specify these values, and these are to be used according with the systems which are being in place. So, here we have, as mentioned earlier, the front and the tail of the waveform. So, typically when you take this waveform, it could be of a switching waveform or a lightning waveform. Switching waveform, say this front time for switching is 250 microseconds, and the tail could be 50% of the tail could be 2500 microseconds. Here in case the flashover happens in the front of the waveform, similar to here if you see the flashover which happens at the front of the waveform at the peak level. So, this is known as the front flashover. Similarly, if the flashover happens on the tail, specified tail of any of this waveform, it is known as the tail waveform. So, the specifications mentioned for various equipments have to be adhered for lightning, switching and power frequency over voltages. There are standards for all the equipments. When we discuss about the testing aspects, we will be looking into the various magnitude of the lightning, switching and temporary power frequency over voltages, what are the values for an equipment to be tested and the time duration to be tested in the future classes. So, before going to that, it is important to know that what is basic insulation level. So, basic insulation level or a BIL is a very important terminology where we have to adhere, and the equipment manufacturers or the utility personnel are to know the basic insulation level of any equipment. So, how it is done, the basic insulation level of any equipment, this is assumed in case when lightning surges or lightning impulse, whatever it is 1.2 by 50 waveform is impinged on any equipment, a over voltage appears across it. This over voltage, the lightning impulse over voltage is discharged as mentioned earlier through the surge protection or a lightning protection devices before equipments of the system gets damaged. So, it is mainly the lightning surges have to see that it will never pass to the equipment. In case if it is a transformer, the transformer should not directly be hit by the lightning surges. So, there is a protection device known as the lightning arrestor or the surge arrestor. These devices should act and see the surges are diverted. So, insulation of such equipment must be designed to withstand lightning or a switching type of surges have to withstand minimum voltages before the lightning impulse wave gets discharged to surge protection. So, this data or this minimum insulation coordination is very important. Therefore, the operating voltage of any surge protecting devices must be lower than the said maximum voltage withstand level of the equipment. So, previous slide we have seen that in case of the transformer and the lightning arrestor. So, the lightning arrestor should act before the lightning insulation strength of the transformer. So, to protect the transformer, the lightning arrestor is used, so that the breakdown strength of the lightning arrestor is slightly lesser than the insulation strength of the transformer. That is the information which has to be known. So, the minimum voltage rating is defined as a BIL. So, BIL or a basic insulation level of any electrical equipment is therefore to see that the protection against the lightning surges is done, and this will help in the long performance or long run of the equipment in the field. So, the table shows here the normal or a nominal system voltages with a reduced and standard basic insulation level for various voltages. So, you can see that for 11 kV the minimum BIL specified is 75 kV. Similarly, for the higher voltages you see the values which are specified both for reduced and for the standard basic insulation level. Reduced could be for the wet conditions or the normal conditions or dry conditions, the standard BILs also specified. In case of 132 kV system, the reduced value of the impulse wave is to be applied is 550 kV, and for normal conditions it is 650 kilovolts. Similarly, for 220 kilovolt system it is 875 to 900 with the reduced impulse level and 1050, that is a 150 kV is the specified limit as per the standards. So, for 400 kV it is 1275 or 1300 is a reduced value, and 1550 kilovolts is the specified BIL for the 400 kV systems. And for 800 kV or 765 kV systems, the value of the BIL is 2100 and 2450 kV respectively. So, any equipment which is manufactured has to be taken care for the basic insulation level to see the equipment performance is not disturbed because of the surges which it encounters in the field. So, this slide I am again repeating as this is a very important information where this factors which determine the insulation strength of any equipment is based on these values. So, above 200 kV, above 220 kV systems, lightning and switching surges play a very dominant role. So, the protection, the BIL values of this equipment have to be seen that they meet the requirements for various over voltage surges. Similarly, for 400 kV and above system, lightning, switching and the pollution or a contamination. This pollution or a contamination we will be discussing in detail. The importance of that, why apart from the lightning and switching surges, the pollution plays a role in the flashover of any equipment in the field. So, higher the voltages, contamination problem is a serious threat to the system, and this have to be taken into consideration for 400, that is a EHV levels and above. So, the design criteria is based on the several factors. Few of the factors we will be discussing are the mechanical and the electrical aspects. So, any insulator, we are focusing on the insulators in the transmission system, where you can see the insulators. I again repeat here, these are the conductors. The insulators play a very important role in the mechanical support to the tower, this tower mechanical support, and to isolate the electrical conductor from the tower. So, various types of insulator assemblies you see at extra high voltage and ultra high voltage transmission. You have tension arrangements, it could be a quadrupole or any twin conductors or a conductor bundle of 6 or more. You have a V type of configuration, you have a suspension type of configuration, a single suspension, double suspension or double tension. So, several of these combinations are being used in the transmission network. So, important function of the insulator as mentioned is to see that it supports mechanically and also electrically it isolates. So, it is required to estimate the maximum load that the insulator will ever see under normal and also overloaded conditions. So, any type of string, it has to take the load of the conductor. It could be a tension mode or it could be in a suspension mode, the conductors, various accessories, the wind, several dynamic conditions, the weight of the insulator, weight of the hardware, weight of the corona control rings, several of these things have to be considered when estimating the maximum load the insulator assembly sees in the field. So, this table gives the mechanical properties of the insulating components which are used for high voltage insulators. You can see here for porcelain, glass, polymer and resin bonded glass fiber. These are the 4 insulator which are being used. So, the mechanical properties for this, you can see the megapascals, there is a units. You can see the mechanical strength required for a porcelain, it will be 30 to 100, in case of glass it is 100 to 120, for polymer it is 20 to 35 and resin bonded it is 1300 to 1600. Similarly, the compression strength of these materials when you see it is 240 to 800 for porcelain, 210 to 300 in case of glass. 80 to 170 in case of polymer and 700 to 750 in case of resin bonded glass fibers. So, these are the mechanical properties of the dielectric components which are used for high voltage insulators. So, the polymer, as mentioned, it could be combination of the silicon rubber and the carbon based with the filler additives. So, this has also the mechanical strength which is required for the transmission systems. So, the mechanical consideration for the porcelain or ceramic or glass insulators is equally important, because when the porcelain or a glass begins to crack or it electrically punctures, that is the information. So, once there is a loss of insulation, the puncture could happen. Initially the surface discharge and later on because of the crack the puncture directly could happen. So, this should never exceed 50% of the mechanical and electrical rating of the insulator assembly. So, in case of cantilever rating, the load, the mechanical load should not exceed more than 40%. These are the standard specified values for the insulator assemblies. Similarly, for non-ceramic insulators or polymer composite insulators, the load should not be more as specified in the standards. Any of the load, it could be the specified mechanical load or a specified tensile load or the routine test load and the rated cantilever load. All these values are informed to the manufacturers and also the utilities, where each insulator assembly depending upon the voltage rating, the values are given and it has to be followed for the smooth functioning of the in the field. So, in case of electrical design criteria, here the two important things are defined. One is the dry arcing distance. When you see any insulator assembly, it could be a ceramic or a glass belts, or it could be a polymer or a long rod insulator. You have two metal fittings on either side, one could be of high voltage, other is the ground. Similarly, this is the high voltage and this is the ground, you have 3 insulators. The shortest distance through the surrounding medium between the terminal electrodes, here we call the earth or a ground electrode or a ground metallic part and a high voltage electrode. So, the shortest distance from this end to this end, the distance which is specified here is the dry arcing distance of this particular insulator. Similarly, from this metal end near the pin junction of the third insulator to the cap junction of the first insulator here, this is the minimum dry arcing distance of the insulator assembly. So, the shortest distance surrounding medium between the terminal electrodes is known as the dry arcing distance. This we will be requiring in case of the testing of insulators when we will be covering the testing aspects. So, similarly, dry power frequency, PF is the power frequency flashover, and impulse, again impulse, it could be lightning which is exponential value, double exponential waveform of 1.2 by 50 or a switching waveform of 250 by 2500, where the impulse flashover or the power frequency flashover tests are conducted based on this strike distance, that is a metal to metal portion of the insulator assembly. Similarly, for wet power frequency flashovers also. So, wet power frequency or dry power frequency, that is at 50 hertz 60 hertz, both withstand and flashover values are decided with the help of the strike distance, the minimum strike distance to be maintained for any insulator assembly. The leakage distance helps in maintain the surface resistance of the strike distance. So, this is an important point to be considered. So, the leakage distance I pointed out, again here the dry arcing distance which we mentioned or which we discussed is from the electrode of the high voltage to the electrode of the ground side. The leakage distance basically is the sum of the shortest distances which are measured along the insulating surfaces. So, you can see that leakage distances, again I stress here, from the pin of the third insulator, it goes through the creepage of the entire insulator and comes here near the cap. The distance from the pin junction completely covering the petticoats or the sheds of the insulators up to the cap portion. So, this is the leakage distance or the creepage distance what we call. So, this creepage distance multiplied by that number of insulators. So, neglecting this distance, this the metal distance is neglected, only the creepage distance of all the insulators are summed up, which is known as the leakage distance. So, the sum of shortest distances measured across the insulating surfaces along the insulated surfaces between the conductive parts in case of arranging like a dry flashover test. So, this is known as the leakage distance. So, now we have discussed about the importance of the insulation coordination, why insulation coordination has to be done for any equipment including the insulators. The second being the important criteria where this insulator or insulator assembly, it could be of pin type insulator or the long rod insulators, how this help in the field both mechanically and also electrically in the transmission system. And we have also looked into the importance of the dry arcing distance and the difference what is the leakage distance. So, this plays an important role in the insulation system to decide for the service conditions which these insulators are used in the field. So, service experience for these three technologies when we look, there are insulators ceramic and glass which are being used since the beginning of the almost a century, where their performance is being done in a and the polymer or a composite insulators are of recent origin and they are being the organic in nature. So, we will be seeing into the service experience of various technologies, the importance of the experience has to be considered and see the failures are improved or the failure rate is come down in the service. So, review of various insulator failure modes in the field, this is again an important information which is required for all the three technologies. So, there we have discussed about the three important technologies, the ceramic or the porcelain, the second being the glass and third being the recent organic type of material composite insulators. So, all the three technologies which are used for the delivery of electrical power throughout the world, particularly porcelain and glass insulators as mentioned have been used since beginning, that is from the start, and have a very good record of performance and also the reliability. So, since a century these are performing and the reliability also is good, but it is not always been satisfactory in some of the cases, particularly under high contaminated or high polluted conditions, and also the performance is not been satisfactory in case of these insulators in service areas which are prone to gunshots or the stone throwing vandalism. So, such vandalism due to these effects have been destroying the shells of the insulator assemblies where the insulation strength reduces and the flashovers have been seen, and this in both the cases serious problems have been noticed where need for costly maintenance, particularly very high maintenance involving cleaning and or replacement of the damaged belts which could cost the utilities dear. So, the composite insulators as earlier also discussed were developed 3 decades ago due to mainly because of the above deficiency, because of the costly maintenance aspects, particularly for the vandalism and also for the performance in highly polluted or contaminated conditions. This was noticed for EHV and UHV levels. So, these composite insulators which were initially introduced during 1980s or mid 80s started being used by the utilities, where initially a lot of learning had to be made. Learning phase, as it is known to the suppliers or the manufacturers, they have to adjust their products through successive failures or through the problems which were observed in the field. So, in this several generation of design based on initial service experience was considered, and the technology was improved at various levels. So, the present technology which is being adopted in the field has considerably achieved the maturity in the polymer or the composite insulator technology. So, in fact, presently in several countries it is considered equivalent and interchangeable with earlier technologies of porcelain and glass insulators. So, several of the places or in the countries the utilities are trying to use the composite newer generation units with the replacing the porcelain or a glass type of insulator assemblies. So, now looking into the various failure modes which have happened over the period for all the technologies, we have seen the failure in case if it is a mechanical separation, that is the insulator string getting detached from the tower or from the conductor. The service experience has indicated that toughened glass strings are significantly less in comparison to the porcelain or composite insulators. So, the performance of glass insulator, particularly for mechanical separation, have shown a better with other technologies. In case of failures involving puncture of the dielectric or insulating body, which is seen or which was seen in the older porcelain insulator units, where the toughened glass was not used and a rare occurrence of this composite insulator was available. So, it was difficult to identify the puncture discs from the ground, because the insulator height on the tower, the being distance. So, the exact identification of the punctured discs was difficult, and it required additional testing equipment to find out the punctured disc for the replacement. Moreover, unless the puncture results in a short circuit, it is not easily detectable in the field. It is very difficult to detect the punctured disc in the field. So, further failures particularly because of the climatic conditions, the cement growth near the pin junction of the insulator or the radial cracking, all this we will be having the pictorial information. So, these have been also reported on the ceramic insulators. This could be due to improper cementing or because problems are hard to detect at the initial stages of the manufacturing. Subsequent to the cement growth or radial cracking, the utilities have come across the pin corrosion. This pin corrosion has happened in the areas of high pollution, which affects the glass or both the porcelain disc insulators, particularly in earlier designs, the older designs. Later on to see that the pin corrosion is reduced for both the technologies, a zinc sleeve was adopted as a countermeasure, as a sacrificial device, so that in case of the corrosion, the zinc sleeve falls and the insulator still is connected to the insulator string. That is the development which happened for the corrosion to reduce. So, further dealing with vandalism, as mentioned, strings with missing either glass or porcelain shell are easily observed from the ground. Although in countries with high vandalism particularly, this means a very high maintenance cost. So, every time the vandalism, because of vandalism, the discs are shattered, the replacement of the disc needs lot of maintenance and lot of time for this. So, the organic nature of materials, that is the composite insulators, have also given rise to failures. It is not that they are completely failure free. This initially a lot of information was tackled and information was noticed, and implemental aspects have been done by the industries and the utilities, and there are failures which in comparison to the porcelain or glass, which are different in nature because of the organic material. So, the tracking and erosion of the housing material is a very important point to be noted, and the surface discharges. This happens, the hydrophobicity loss, the tracking, the erosion of the material, the surface discharges are noticed. Then the material, the surface of the insulators or the polymer material, sheds of the polymer material are observed, or the birds pecking by the birds also was observed, and the silicon rubber has been is being damaged because of the birds. Tracking of fiberglass rods was also noticed, and brittle fracture are some of the possible modes of failure reported by the utilities. So, despite all these issues or problems, the composite insulator technology is being growing, is improving, and significantly is being also coming up with the newer remedies, and is being used in the present conditions in many of the utilities across the globe for voltage levels up to EHV and UHV systems. Ceramic and glass, looking into the summary of the failure modes here, as mentioned, the ceramic or porcelain or a glass insulator are being used since 1830s, initially for telegraphic systems. These insulators are used for various voltage levels, from a very low voltage to a voltage level of 800 kV AC systems or 800 kV DC systems. This have provided greater flexibility because of the cap and pin. They are very strong in compression and available in various shapes, and the construction is very simple in construction. You can see the metal pin and the cap surrounded by the porcelain or a glass shell. So, these have a high degree of standardization, various types, size used for various locations. It could be for normal conditions, desert conditions where aerofoil type of insulator is used, or in the conditions of contamination where anti-fog insulators are being used. So, for HVAC and also for DC systems. Some experience with ceramic insulators were also discussed. So, electrically they are fairly stable over the time, almost a century they are fairly stable. Mechanically they are subject to deterioration over the time period, and some issues were also noticed in case of the ceramic or porcelain insulators over a period of time. This could be the flashovers which have been noticed because of the surface getting degraded, punctures, this could be because of the cap and pin failures or the punctures happening. The cement growth, as mentioned, this is again due to the expansion because of hydration, which causes the radial cracks or punctures in the head, which have been noticed in the utilities. The pin corrosion which we discussed, this again to counter this pin corrosion, a zinc sleeve has been also being used. Long term mechanical and electrical strength reduction over a period of time was noticed. Then coupling hardware corrosion. So, because this hardware which is connected to the insulators and the conductors happens to be in the outdoor system, because of the climatic condition or the environmental conditions, the hardware corrosion also has been noticed, which degrades the insulator assembly. So, these are some of the failures or the changes which have happened to the insulator, porcelain or ceramic insulator. You can see here the surface of the insulator, the complete glaze has been removed over a period because of the climatic conditions, and here we see the breakage of the sheds. This will definitely lead to the flashover and the reduction of the insulator strength. A typical radial crack arrangement you can see because of the pin and the cement and the ceramic shell junction, the cement growth happening, and there could be a radial crack which further the puncture of the insulator could happen. So, further to this, the insulator can get detached mechanically, that is the cap and pin of the insulator failures have also been noticed in the field where detachment happens. This again is one of the typical example of the lightning phenomena in striking the insulator assembly, where due to the lightning the failure of insulator assembly has happened. So, several of these failure modes have happened due to corrosion, hardware corrosion. The damage could happen due to the pin junction where the cementing, Portland cement giving away, or the growth of cement could damage the insulator and helps in the puncture of the insulator. So, this have to be clearly taken into consideration before the line. And apart from this, there are natural conditions which we discussed. These are again the man-made or the conditions which, because of the growth of industrialization, where because of the burning of agriculture waste, you see the ash settling on the insulator surface over a period of time, because interacting with the dew, fog, the insulator flashover do happen. Similarly, the insulator or lines which EHV or UHV lines which are passing near the industries. So, lot of the smoke from the industries or the big kilns or from the cement industries or from any of the chemical industries, these pollutants or the contaminants settle on the insulators over a period of time, become brittle, then become conducting because of the monsoon conditions or because of the fog, dew, or the layer which is formed there conducts and the flashover happens. These are for the various contaminated conditions which have been accumulated over a period of time. As I said, it could be of any industrial contamination or because of some places where large birds are nesting, and large birds create issue where bird droppings further degrade the insulation or reduce the insulation strength. So, several of these are to be considered by the utilities in smooth functioning of the transmission network. So, we will look into the non-ceramic insulators similar to the polymer, porcelain or glass in the coming class. So, we will stop here. Thank you.